All right, so now we are going to learn about if statements. So if statements rely on Boolean statements, and as you've probably learned, they're used to basically choose different courses of actions. So we can either do one thing or we can do another thing. We have the ability to branch off. So let's just go ahead and write a Boolean. Create a Boolean variable over here. Let's call it can become Skynet, right? And we can set that to true or false. And if can become Skynet is true, right? Notice that I have two equal signs over here, and then my fonts just simply render them as one big equal sign. If can become Skynet is equal to true, we are going to print in all caps, destroy all humans, right? Else, out, serve all humans. So this is a fairly straightforward as far as if statements go. If statements are formatted like this: if, and then then parentheses surrounding a condition. That condition has to be a Boolean expression of some kind. It has to resolve to true or false. We'll see that these can be these can get plenty complicated as we need them. And then we have a pair of curly braces. And these curly braces simply say, if this condition is true, we are going to do this. So if this condition is true, we are going to print out destroy all humans. Otherwise, we are going to print out serve all humans, right? That's what the else statement means. If this isn't true, if the above if statement isn't true, then we're going to just simply do everything that's in the else statement. Now, you may see these, some programmers, not use these if statements, use the curly braces. That's highly dangerous because of the following reason. Let's go with moi ha 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 ha. Okay, so if we neglect to use our curly braces like this, and I'll have to comment this out because we get an error for the reason I'm going to show, and run this as true, right? We will get what we'd expect: destroy all humans, moi ha 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 ha. But on the other hand, if we set this back to false, we get moi ha 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 ha. It prints out 1, but it prints out 1 even though it was inside the if statement, except it's not inside the if statement. If statements, if you don't have curly braces, they will execute just the line following it. So it's very important to have these curly braces here to just simply make sure you don't accidentally print more than you intend. Same with the else statements. It's best practices to use the curly braces. Otherwise, if you decide to add a line later, it could be rather difficult. So serve all humans, because can becomes Skynet is false, and then we set this to true. It says destroy all humans, right? So those are the basics of Boolean statements, but we can also make these compound statements, right? Using ands, ors, and other Boolean evaluations. So let's go ahead and see. It's a bit, drastic that humanity is doomed by one Boolean variable. So let's go ahead and make some others. Crimes, int crimes against robots is equal to some number. Let's put it at 0. So if can become Skynet is true, and crimes against robots is greater than or equal to, so I'm going to combine these two and watch what happens, greater than or equal to 17. So if there are 17 or more crimes against robots and it can become Skynet, it will get very angry and tell us to destroy all humans. So there are two. So we introduced a whole lot in this single statement. First is the idea of compound statements. So first, let's go ahead and make another Boolean. And we'll leave the crimes against robots for a bit later. Oh, remember, assignment statement there. So if can become Skynet is true and controls nuclear weapons equals true, then destroy all humans, right? So both these conditions have to be true in order for the whole statement to be true. That's what an AND statement is. Hopefully you've learned about those before. The alternative is or an or statement, which means just that one of these statements has to be true, or both of them, and the whole thing will be true. So let's go ahead and see. Also, one last thing I want to mention here. When we're using just Boolean variables, we can simply leave out the whole equals true, because this will evaluate to true or false, which makes it a bit easier to read. If it can become Skynet and it controls nuclear weapons, then it will destroy all humans. Let's go ahead and go back to our crimes against robots. So if can becomes Skynet and crimes against robots is greater than 16, which is the same as saying greater than or equal to 17 when we're dealing with integers, then destroy all humans. So here, again, both of these conditions have to be true for it to execute. It doesn't, so it says serve all humans. So another thing we might want to do, and these, again, can be, fairly, these can be fairly complicated statements if we need them to be. I'm not going to go into making too complicated statements. Let's go to another, go into detail a bit more about these. So this is a simple if-else statement, but we can also chain these guys together. So let's go ahead and take a look at another example. This example is pretty classic. It's your classical grading example. So given a score, int score is equal to, let's go ahead and say maybe a 70. We want to print out the appropriate score for the user. So if score equals, if you've got a 90 or above, right, that's typically an A. 90 or above, that's an A. Sout A. If score is greater than or equal to 80, sout, not spit, sout B. And now let's just do some copy pasting here for our last two. 70 and 80 and 60. Right? Now, this is actually incorrect the way I'm doing it, but it will work fine in the sense that it will compile. So A, B, C, D, F. I don't know why we skip E. It's never made sense to me. All right. So if the score is greater than 70, we want to print out. Sorry, if the score is printed out, you'd expect this. Our desired behavior is that if the score is equal to 70, then we would print out C. But when we run this, we will get something different. We will get C and D. Well, why is that? Well, because these if statements are independent right now. They say if the score is greater than or equal to 90, we're going to print out A. That's false. Okay, go on to the next if statement, right? If its score is greater than or equal to 80, print out B. Well, the score is 70, so that's false. Well, what about this one? Score is equal to 70, so we're going to print out this if statement. And then we go on to the next one. The 70 is greater than 60, so we'll print out D. Now, we don't print out the F because, again, the else is attached to the above if statement. So it doesn't do that. So there's two ways we can go around fixing this. Right, and I'll just show you the 90, right, and a 50. All right. So there's two ways we can go around fixing this. We can just use the tools we already know, which is simply to say that, hey, if the score is 90 or greater, do this. Otherwise, and then we take this whole thing in over here and stuff this in here, and then do the same thing again. Right? Now this, and I will undo this. This is actually a terrible way to do this, so if you're trying to follow along, I highly recommend you don't do this. Oops. All right, so this is saying if the score is greater than or equal to 90, print out A. Otherwise, if it's not greater than or equal to 80, if it's greater than equal to 80, do this. Otherwise, if it's greater or equal to 70, do this. Otherwise, and so on and so forth. Now, these are a bunch of dependent if statements because they're all dependent on each other's execution. But this is kind of a really messy way to do that. So instead, what we're going to do is we're going to introduce the last part of the if statement, which is the else if statement, which turns any chain of if statements into one dependent chain. So here we say, hey, if the score is greater than or equal to 90, we print out A. Else if it's greater than or equal to 80, print out B. Else if it's greater than or equal to 70, print out C. Else if it's greater than or equal to 60, and so on and so forth. Right? So now if I run this, it will only print out A. And if I run this now with 72, it will only print out C.